So there's a couple of different key terms here. There's isometric drawn, which is where we use the same scale to draw something. And then there's perspective drawn, which is basically where we are drawn a 3D object in a 2D shape. The objects are going to be smaller, and we use a vanishing point to create a sense of depth and space. Well, that'll make more sense shortly. There's going to be a horizon line. This is a horizontal line. This will make more sense shortly. The vanishing line also make more sense. And then an exploded diagram. If you've ever, has anyone here ever built IKEA furniture? Has anyone here ever built like IKEA furniture or like Wayfair or something like that, where you will have seen exploded diagrams before? Like I will show you, you'll see an example and you'll be like, oh, that stuff. But basically that's where it's all the parts of it that are put together, but then they just like explode it out. So you can see how they all kind of fit together. Yeah, Legos would be a good one, actually. Yeah. Yeah. So you've seen these before. So what we're going to do is, so isometric dot paper is this stuff here. So we're going to be learning how to do this. So this is just an example here that you can kind of see. I just kind of threw it directly in here. But basically, if we wanted to use isometric dot paper to draw a cube with sides that are 3 units long, you're going to notice on this next page here. So this stuff right here, this is isometric paper. All it is little dots that are equally spaced apart. If you guys go down one, you're going to see that we have some as well. You know what? I'm going to print some of this off just in case right now. Give me a few seconds here. What page is that? 27?
26.
Okay, there it is. Oh, that was me. That's not supposed to be there. Okay. So we're going to eventually end up using this stuff. I'm printing off some extra copies just in case. But you can also see, again, I'm just giving you guys some pre-made examples here. We're going to end up doing this stuff, but this here would be an example of a perspective drawn, which, as you can eventually see, if you go to the final product here, a perspective drawn is eventually it vanishes to a point. It goes on and on and on and on forever. You would have seen this in movies, for example. So we're going to end up doing this stuff. And then I've just included straight up examples for all three of these different types of drawing. We have isometric, where it's drawn on this dot paper. We have perspective, where you're seeing the perspective of something. And then you have exploded diagram, where that's what an exploded diagram is. So if you've ever done IKEA furniture, you would have definitely seen something like this. So does that make more sense? Like, it's literally they've taken the final product and they've exploded it. And you can see we have those nice fine lines over there. Okay. So let's try and practice some stuff here. We're gonna jump straight into it. Yeah, I think we will start with question one. I meant to swap these, but we'll keep it this way. So in this, we have an isometric drawing of a room. You can see how this is a pretty useful thing. This is a lot of what is done in various different types of design programs, for example. They just don't have the dots in it. But in this case, if you were drawing it by hand, you would have the dots. So this was used in blueprints back in the day. So this is an isometric drawing of a room where the front wall is 18 feet long. And we want to be able to find walls X, wall Y, and the height of the room. Those three things. Now, just like with graphs, this is technically a part of a graph. And just like with the drawings we were doing earlier, we have to keep things in scale. So here's what we know. We know that this length of this wall is 18 feet, right? How many dots are there? There's 1, 2, 3, 4, 5, 6, 7, 8. Oh, there's 9. Sorry. There's 1, 2, 3, 4, 5, 6.
Well, are you counting?
Oh, there's 10 dots, but I'm counting the distance. So I can see if I go from one end of the wall to the other, it goes 1, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Old Mac sneeze. Sorry. Okay. So the wall itself in real life is 8. Come on. Excuse me. There we go. Okay. So the wall itself is 18 feet, right? But I can see that this is kind of set up in 9 different distances. So what does this distance represent? This little blue line. How long would that be in real life? 2 feet. Yeah. Right. Well, I know it's 18 feet in total. I know it's broken up into 9 parts. 18 divided by 9 is 2. So each one of these dots now is going to end up being 2 feet. Yeah. So that's not going to be that hard to figure out. So if I wanted to figure out the length of this wall here, what would that be? Yeah, it'd be 2, 4, 6 in total. So there's no real complicated math with it. All we had to do is we just had to figure out the scaling. We just had to figure out that, well, I know that the whole wall is 19 or 18 feet, and I know it's broken up into 9 parts. So my scale in here is every one dot I go is going to be 2 feet. So what about y? How long would the y wall be? So it'd be 10 feet. Yeah. So y in this case would be 10 feet. And what about the height? So go 1, 2, 3. So it'd actually be 8. Now there's 5 dots in there, but I'm counting the distances between them. If you think about the graph, you can almost think about like I'm counting the white spaces between the lines in the graph. This is the same way. Essentially, yeah. I'm looking at how far the line itself actually travels, not how many dots it goes through. And so yeah, the line travels 4 times, which makes it this whole thing 8 feet. Right? So the math itself is not hard, but it's really important that scaling is kept intact. So x is 6 feet, y is 10 feet, and the height h is 8 feet. So not that hard. There's no like real math involved in this. It's just figuring out the scale and count it. Now, drawing it is pretty similar as well. Like we've already shown, we know how to draw stuff, but the biggest thing we need to keep in mind always, whenever we're drawing anything, is we need to have the scaling correct. So I'm actually curious because I want to take your ruler. I'm hoping this printed out okay. How long is it from this line to like this line? Like, just what's the distance between 2 lines?
1 centimeter.
Is it exactly 1 centimeter? Okay, good. That's what it's supposed to be. So each distance we go here should measure out exactly 1 centimeter in like real distance. Okay, I didn't screw up that scale and then good. So if I'm making a line like this, I would know that this line here is 3 centimeters, right? So perfect. So that's going to make it really easy. We don't need to like do a lot of really difficult conversions. So let's go to this actual question here. So this actual question wants me to draw this shape below as an isometric drawing using a scale of 1 to 20. So when we're doing scales, is it model to original or original to model? Model to original, yes. So does that mean the 1's going to be the model, which is our drawing? Yeah. So the 1's going to be our actual model here. This is always model. I'm going to type that. Let's make that non-messy. It's always model to original. Let me make that bigger. Maybe make that red. Right? So the 1 is the model, the 20 is the original. So what does that mean? Well, it means for every 20 centimeters that our model goes, we're actually only going to draw 1 centimeter, right? So if I'm looking at this actual model here, well, I can see I actually have a figure here that has 20 centimeters. So how much am I actually going to draw that? 1. So what I'm going to do is I'm just going to really quickly in a different colored, like, so I'm going to use red here. I'm just going to do the conversions right now. I'm just going to do my conversions and then I can quickly draw it. So I know the 20 centimeters is 1 centimeter. How many would 30 or how many would 60 be? 3, right? 60 divided by 20 gives me 3. How much would 100 be? 5. Right? This is as hard as the math itself actually gets. You're just converting from a scale to another, and your calculator can do that hard work for you. 40 would be 2. And we already know that 60 would be 3. Now, I don't need to know the length of these 2 red lines, do I? Because all I'm going to do is it's literally connect the dots. I don't need to know the lengths of these. I could figure it out at this point. We know enough about math where we could figure out that, you know, oh, this is 40. This is 20. We use Pythagoras. We could figure it out, but we don't need it. Well, yeah, we just need to connect it, right? We're just drawing like, because it's just going from this point to this point. Yeah. So let's quickly draw that in here. So this is where most people tend to struggle with it is. And so we're like, the math itself is not that difficult here. One of the things though is sometimes we just need to think a little bit ahead. So if I'm drawing this, let's say if I want to start with this corner right here, I can't start this right here, can I? No, like I need to have enough space to be able to do it. So sometimes that's going to matter. In this case, this drawn is so small that like the biggest one we go is 5 centimeters, 5 of these lines. So I'm just going to kind of go down. I know I need to go at least 2. I know I need to, it's at least 2 and 5, right? It's too tall, 5 wide, and then it goes up another 3. What I'm going to do is I'm just going to start like somewhere down here on the bottom corner. So where I put those 2 red dots is where I'm going to start matching it up. So that's my starting point. Just pick a point to start. And so how high up do I need to go again? 2. I need to go up 2. And then how far across do I need to go? From the bottom. 5. Yeah, so now I'm going to go 5. So using your rulers, 2, 3, 4, and 5. So now though, I like doing the border of it first. And you notice I'm actually drawing in like on red, like what I've just done. So now what I want to do is I want to do this little slanted line. The slants, the diagonals, that usually causes some confusion for people, but just like how we can see here, you can still go, I need to go 3. I can still go 3 in a slant. That's fine. And then it raises up 20, which we know is just 1. Now, here's my question for you. I'm going to use blue to represent this. I'm going to make it a thick line. How tall or how long is this line, this blue line? 3, right? I know that this is 60. This is 60. This is 60. That's also 60. So that first blue line, let me just erase the other ones to make more sense there. So that blue line I have there, well, the line itself needs to be 3 centimeters long, and it's a little diagonal, and it's going the exact same angle. So just like this one, I'm going to move up 3. So again, I'm just drawing it in as I go. And then I know it needs to get moved another 3 purely to the right. You notice that I'm doing the outline first. And so then what do I have to do? I just have to connect my dots, right? I don't need to actually figure out how long this is, because to complete the drawing, all I have to do is just, let me make that a little bit neater though. Sorry, I'm just going to make my drawing a little bit neater. I don't have a ruler, unfortunately.
Do you need to use a ruler for this? Since it is just
If you have a really good hand, no. Yeah, if you have a good hand, you do not actually. I, unfortunately, am a very shaky person. So no, I kind of have to. So I've done the outline. Now what do I have to do? I need to draw the inside part, right? So I'm going to go to the same corner. I notice that this line goes up one. I'm going to go up one. And then it goes another 3 diagonal. I'm going to go 3 diagonal. And again, you're noticing that I'm actually shading along the outline of the model drawn. Now, this line right here, the one I'm kind of drawing in dots on the very top here, how long's this line? Yeah, that one's 3 centimeters, right? It's not 5 centimeters, it's 3. And then I know this line here is 3 as well. So all that stuff we did in the unit 3 with like the surface area and stuff, that's kind of coming in to help us now with composite shapes, etc. And now all I need to do is I just need to connect these 2 lines, and now I should have my shape, right? Like that looks about to be the exact same shape. Let me clear all my markings up here. So once I put it in, I just take a quick look at it. Does it look right? It seems to be the same shape. It seems to be the same proportions. So yeah, I think that's fine. I've done my job. I've labeled it. So that's it. Like that's an isometric drawing. The math itself wasn't hard, but we just had to pay some attention to detail, right? Figure out our scale and then make sure we're doing the right lines, we're using the right measurements. So what I'm going to have you guys do here is I'm going to have you guys try out this one. Now, before you jump into it, what are we missing from question 3 that we had in question 2? The scale. Up here, I knew that I'm doing a 1 to 20 scale. Now, does this seem a little small too? A little bit. We probably could have made it a little bit bigger. There's no fine art to it. So I know that in total, how high up is this one going to go? 300. And it's going to take a total of 27 or so 270 going across. Like, what do you think might be a good scale? I don't actually know how many dots are in here. 1, 2, 3, 4, 6.
30.
There's 30. Oh, for going up here. Oh, you're making a scale. I think a 1 to 30 could probably work actually. I think 1 to 10 might be too small. So either going, so you're right. So like we're looking for easy numbers, right? Like how can you break? I'm just throwing some examples here. These are just some examples. I'm picking easy numbers that look like they're probably going to work. I'm looking for, it's called a common factor. So 10, 15, 30, those all seem like they work. 20 seems like at first it's going to work until you get to the 270 and 90. Now, in this specific case, you don't want to try and include half distances if you can get away with it, because that is going to cause some problems if you do that. So 1 to 10 seems too small. So I'm going to recommend you go with either one of these 2 scales. If you do that, there's definitely at least 20 lines going all the way up here. So it will work. So I'm going to give you guys an opportunity to try drawing out this thing here. So you can pick whichever scale you want. I'm fine with it either way. I'm going to give you guys about 5 minutes to actually draw this out. I'm going to come around in 2 minutes and see how we're doing. So the big, really important part there really is that scale and component of it. Now, we're going to actually try and draw ourselves a perspective image now. So you've noticed on this one here, if you need a quick reminder, I'll just move it up here to kind of show you a perspective image. I've given you a full study example directly on it here. Perspective image is where we are going to, we're showing off a 3D object in 2D. So it's going to get smaller as it goes in a distance, and we eventually make it vanish entirely. So this right here is an example of a completed prism here. So we're going to try and do this. I think that's on page what, like 27 or something of there. So let's try and do this. So we already have ourselves our two horizon lines. So we're going to draw two perspective drawings of this, and we already have two vanishing points that are given. It's already told us this. So what that basically means is eventually it should get something where it's going to eventually just vanish entirely. Oh God, I really wish I had rulers. It's going to eventually vanish entirely. So basically what we need to do is you need to connect your ruler from each corner to this point. So I'm going to line my ruler up from this top left corner to this point, and I'm going to draw a nice straight line to it. Yours is going to look a lot better than mine because I do not have a ruler. And then I go from the top right one. And I draw a nice straight line there. Again, I'm doing it as best as I can without a ruler. And I'm going to use the bottom right line and do the exact same thing. Okay. And you're going to notice it's a little weird. That one's done on purpose. So now we're actually going to do B. And this one should end up looking quite a little bit different. So I'm still going to draw, just like before, I'm going to start with my top left. I'm going to draw myself a nice line here. I'm going to use my top right corner and do it as well. I'm going to use my bottom right corner and do it as well. I will talk about that. I will talk that is done on purpose. Yeah.
So should I put that in as well?
Yeah. Yeah. So give you a second. So which of these two looks better? B. B absolutely looks better because it's actually a 3D object. I've turned a 2D shape into a 3D perspective. The reason that we've done both of these, the reason that B looks better is if you're looking at point A, and I'll just kind of show it from the other perspective too. Oops. So hard when I'm doing it like this. Oh my God. I can't even do it without a ruler. Well, the reason that B is just looks so much better than A is if we see where this A is above, like relative to the shape, it's just right above it. I need it to actually be a little bit away from the shape. You notice how point B is further away from the actual shape. That's what lets me turn that into a 3D object. So the point itself needs to be outside of where the shape is. If you do not have that, it's not going to turn out okay. You're going to get something that looked like A before, where the second my line has to go through my shape to get to it, I don't have a 3D object anymore, do I? It doesn't work. It's not because the perspective of it changes. So Now, what if I wanted you to actually turn this into a 3D object? How could you do that? Well, all you have to do is you have to take a nice straight line that goes across, and then from that, cut it down. Now, I have to connect it again because this is just what I have with my computer. But all of a sudden, you can turn it into a 3D object still. So all you have to do is draw a nice flat line and then go down, and it will end up working. Like I said, I'm stuck on a computer, so it's a little bit more difficult for me. So let's try it now with a little bit more complicated shape. So how come I never did how come I didn't do the bottom left corner of shape B? Any guesses? Yeah, because it kind of ruins the perspective. My line should not go through the middle of my shape. I'm not trying to find what's inside the shape. I care about creating a 3D object. I'm not trying to use an X-ray on it. So as long as my line's able to connect to it without actually going through my shape, I'm doing okay. So just like before, I'm just going to connect my 2 points. So connect the V to my top left corner here. Now, this top right line is not going to go through my shape, so that's good. So that will work. This bottom right line is not going to go through my shape, so I can do that. Sorry?
That little corner there doesn't go in the shape like
This one? Yeah, you're right. So this one here is not really gonna. Well, actually, we'll think about it. This one here does. Now, this bottom right corner, is that gonna fit into that line without going through my object? No, it's gonna clip through my object, so I'm not gonna do it. So in this case, that's totally fine. So it's just gonna be those 3 points. Those are the only 3 I can actually manage. And then how do I finish this drawing off again? So just like I'll use blue to kind of represent it. So in this blue line here, well, what I'm representing in blue, I'll erase it right now, but that blue line, that's a nice flat straight line, right? So that's the exact same thing I need to go and do just anywhere up here. It could be right here. It could be right here. It could be right here. I'm just picking any point. I'm going to do that same flat line, that same line, whatever's there. And then I see it goes down and then right. I'm going to go down and I'm going to go right. And then all I do is I just erase that top part. Now, I can't erase it because of how like the program works. So I need to redraw my actual lines. Oh, actually, I can get away with that. I can do that. Okay. I've just thought about a different way to do this. This would work so much better. And all of a sudden, I now have a 3D shape here. And it turns out, again, if you're ever unsure, well, if I look at my final object, oh, I actually could have done that probably. Like you can always add more lines to it after if you want. So this next one here, what makes question 6 harder than the ones we just did? They're both perspective drawings. I need to draw the horizon line, right? This right here is called a horizon line. And I also need to add the vanishing point, right? That's our terminology from the very, very start here. So I need to add that stuff. So how do I draw a horizon line? Any guesses?
The straight line.
Just a nice straight line across. Yours is gonna like what you're seeing here is gonna be the worst of the worst because like this is the best. Wait a minute, is there a way I can get away with this?